welcome to this tutorial. Today we're going to be covering an advanced outline post-process material in UE4 and 5, and this is going to allow us to pick out all the little details in the models in the scene by manipulating the world normals. Though we will be using the custom depth stencil in this tutorial, so if you haven't got that activated, you're going to need to go into the project settings and make sure that it's set to with stencil enabled. I'm currently working on a game called Button Pop. I'd really appreciate it if you guys can go on over and wishlist it on Steam, but also give the demo a go and let me know what you think. If you have any feedback or want to see your own hat or button in the game, leave a comment down below. And with that said, let's get into the tutorial. Alrighty, so let's first make a material. So if we right click here and go down to materials and into material, and we call this ADV_outline. And we double click in there and open this guy up like this. And the first thing we're going to do is change the material domain. So if we click the little drop down and go and stick it to post-process material, and we go all the way down to the bottom and you find blendable location, just turn this to before tone mapping so that the anti-aliasing can affect this material. And the actual core of this material is the world normal. So if we right click and type in scene texture, and then on the little drop down we find world normal, chuck this guy in here, you'll see these funky little colors, and this is a sort of representation of the detail in the scene. So if we go back into our scene here and find our post-process volume, and we just get rid of our original one now, add a new element, asset reference, and we make a instance of our material by right clicking and going to create material instance, and we just drag this guy in here, and this is our material so far. Looks weird. Now, as I said, the base of this material is going to be using the world normal, but we are going to have to compare different pixels to each other, so we're going to make a sort of ladder effect here. Now, just to kind of simplify things, we're going to use material functions, which should just streamline things a little bit. If we go back to our content browser and we right click and go down to materials, and we create a material function, and we call this sample offset custom, and we duplicate this, and we call this one sample pixel normal, and we duplicate this again, and we call this sample pixel depth. Cool. Now if we double click on our sample offset custom, and this guy up here like this, this is similar to a function in Blueprints, so we can use this within our material just in a minute. So if we right click and create an input like this, we're going to need this to be a vector2. We just set that there, and if we name this offset amount like this, just give ourselves a wee bit of space here, and in this function we're actually going to be creating the positions of the pixels we're going to be sampling, and then we can reuse this function as many times as we like. So if we left click and press the 2 key, we'll create a 2 vector like this, and we're going to want to multiply this. So if we click M and left click like this, we multiply this. We want to multiply this value by the offset amount, so we put this guy into here, and we're going to have to create an output. So if we right click and type in output, function output, and we want to name this output 0, 0, this, and fire this guy into here. Now we're going to have to create one of these for every area around a pixel. So if we duplicate this 9 times, or 8 times, sorry, and we just line these guys up, and we connect this guy up to here on all these lines, like this. Just move this guy down here so we can see things a little bit better, and what we're going to need to do is change the offsets for each one of these so that it's a different area around the pixel. So the first one is going to be 1 and 0, and we're going to change the output name to 1, 0. And the next one is going to be -1 and 0. And the one after that is going to be 0, 1. And the next one is going to be 0 and -1. And the middle one here is going to be 1, 1. And then it's going to be 1 and -1. And then the second last one is going to be -1 and 1. Oh. And the very last one is going to be -1. Oh, -1. Cool. And you can add additional steps that cover even more detail, like the in-between parts of these steps, by assigning a 0.5 value instead of whole numbers like 1. I'll include all of this in a paste bin down below, just so you don't have to, manually do all this stuff. And that paste bin will actually include the -5 as well. Alright, cool. One last thing is to go over to the left here and expose it to the library. And this is going to allow us to call this in our actual material. So if we apply this and save, and go into our material, and right click, and type in sample offset, like this. This is going to allow us to actually offset this guy with these values. Alright, cool. Now if we go back out to here, and we double click on our sample pixel normal function, and we open this guy up here, we're going to create a small toolset so that we can manipulate our world normals over and over again for every area around a pixel. So if we right click and create a scene texture and set this to world normal like this, and if we drag out here and mask this, type in mask and go down to component mask, and we want this to be RG and B, and we want to put this into a multiply and chuck the multiply into the output result, and we're going to drag out of the B channel of the multiply and create an input, function input, and we're going to call this offset, and we're going to make sure that's a scalar. Cool. Now if we go over here and we right click and create a texture coordinate, like this guy here, and we add to this and chuck this guy into the UV pin here. Now if we drag out here and create a multiply, and we're going to multiply between two different values here. The first of which is going to be an input, function input, and we're going to make sure this is a vector 2, and we're going to call this pixel position, and chuck this guy into the multiply here. And just for safety, we're going to create a 2 vector here out of the preview. So if we left click and click the 2 key and just chuck this guy in here just for preview. And if we go down here and we drag out and we create another input, and this time change this to a vector 2, and we're going to call this Texel Size. Cool. And the last thing we need to do is expose to the library. Apply and save. Right, so if we go back to our material in here, and we right click and type in sample pixel normal like this, you should have a node like this. Alright, so the first thing we're going to need to do is create a parameter for this guy. So if we left click and press S to create a parameter, and we call this offset amount, and we just put this to 1 for now, stick this guy in here. Cool, now I've just noticed one thing, these are actually out of order. So if we double click in here, and we go to our outputs, we can actually sort the priority. Now what I like to do is just do it in the order that we've actually got it here. So if this is 0, this is going to be 1, 2, 3, 4, 5, 6, 7, 8. Cool. if we apply that, save, go back to our material, it should be in the right order. Okay, cool. Now, if we connect up our 0, 0 to the pixel position, now we just need to find these guys. The first thing we're actually going to do is the Texel Size. And if we just go over here for a second, just to give us a bit of space, and we right click and type in scene Texel Size, and we drag out here and multiply and create a parameter here by left clicking and pressing S, and let's call this inner outline offset, and just stick this to 1 for now and chuck this guy into here. And if we drag out here and create a breakout float 2 components like this, and we clamp both values like this, and if we duplicate our parameter over here and rename it to Texel Size inner clamp and just leave this as 1 for now, and we're going to divide this by 1000, and you're going to want to chuck this guy into both max values here. Cool. So now if we chuck both of these values into a make float 2, chuck the both of them into that. Now if we're in Unreal 5, we can create a declaration reroute node that we can call from somewhere else in the graph. So let's name this Texel Size, connect this guy up, apply and save. We can now go back up here and call the Texel Size like this. But if you're not in Unreal 5 and you're in Unreal 4, you're going to have to manually pull this guy up here and connect this directly, like here. And whenever we duplicate this around, you're going to have to connect this up directly instead. Cool. We'll just name this Texel, like that. Cool. Now the last thing we need to do is get the offset. For the 0, 0 value, which is the center of the pixel, we're going to need to create a constant by left clicking and pressing 1. And the middle of the pixel needs to be set to a value of 8, like this. But all the area around this center needs to be set to -1. So if we copy this down here and we drag this guy out into the pixel position, and we set this to -1, like this, we're going to have to add these two together. So if we create an add and connect these guys up like this, and this is pretty much what we need, like this. But we're going to have to do this for the rest of the values and create a sort of a ladder effect. So if we push this guy over here, get rid of this guy, give ourselves a wee bit more space, and duplicate this guy down, and just start to create our mini ladder effect here, like this, and just start connecting these guys up. So this into pixel position, and this into pixel position, and this into pixel position, like this, 2 more times. And we'll also have to add these guys in too. So if we make an add, and if we just go all the way up and add them together, last one, chuck this guy into here, you'll start to get this sort of funky look, which is pretty cool. It's almost like tartan actually. And the basic principle of all of this is that each of these are positioned around a pixel. So 0, 0 is the center, and these are the various areas around a pixel. So if we have a look in our scene, we're going to have this look. And as you can see, we're starting to get the sort of outlines, but more detailed, which is pretty cool. Okay, but we do need to convert this to a sort of black and white mask, grayscale kind of mask. So if we go back into our material quickly, give ourselves a bit of space, and we drag out here and we mask to our component mask, and we duplicate this so that we have 3 of them, and we're going to do 1 per channel. So If we do R, G, and B, like this, just connect these guys up, like this, and we're going to multiply these by a value. So if we go down here and create a parameter by left-clicking and pressing S, and we call this normal intensity, and we put this as something like 50, and we drag out and we divide this by 100, and we're going to multiply these values with this. So if we drag out and we multiply, we duplicate these down here like this, and we chuck this guy into these values, and we want to get the absolute maximum value from these. So if we drag out and type in max, like this, and we put this guy into B, and we duplicate this up here, put A and B, and we want to saturate this, just for safety, chuck this guy into emissive color, you'll see that we have our grayscale mask. Apply this. Sick. Nice. Cool. Now if we go back into our material and just give ourselves even more space, like this guy here, and just for a little bit more control here, if we drag out and put this into alert, and put this guy into the alpha, and if we create two parameters here, a sort of min and max, so if we left click and press S and name this contrast min, and then in brackets normal, and we duplicate this down and we rename this to the max version of it, and let's say as default we say 0.3 and 0.05 for the min, these guys into here. And just for a little bit extra control, if we drag out here and put a power, so we can sharpen it, and right click and create a parameter, and we name this one normal sharp, and just set this to 1 for now, we should have a pretty good base for our outline material. Cool. Now there's a couple of things we need to sort out. First of all, this will have some issues with depth, so we're going to have to duplicate this for the sort of depth section of this. So what we can do is if we duplicate this guy over here, and if we take all of our add nodes and duplicate this guy down here as well, just kind of keep that roughly the same. And we created a function just for this. So if we go into our pixel depth function, open this guy up, and just before going in here, if we go to our pixel sample pixel normal and open that guy up, and we just copy all of this stuff, Control C, and go back into our pixel depth function and paste this in here and connect this guy up to the output. And instead of the world normal, we want to set this to the scene depth. And all we need to do is make sure this is exposed to the library. Click that one, apply and save, and we can close this guy down. And if we go back to our material, like here, and if we right click and type in sample depth, sample pixel depth, like we made before, you should have a node something like this. And we want to do the exact same as what we've done up here. So if we duplicate some of these values, so if we get the two of these, come down here, and we're going to want to make sure this goes into the offset, this goes into the Texel Size, and these values are plugged into the pixel position. Cool. Now if we just duplicate this down, just like before, and plug these guys in, just like this. And you're going to want to make sure that all these values here are on -1 except for the very top one, because that's the center of the pixel. Alright, cool. So now if we add all these guys up, just like before. Whoop. Just like that. If we just move this guy up a tiny wee bit here so that we can see where it is. And we're going to want to pull out from the pixel depth ladder and divide it by a parameter. So if we right click here, create a parameter, and we call this depth intensity, and we put this to 8 for now. And if we chuck this guy into an invert lerp, put this into the value, and we'll set this to 2 and 100. We drag this guy all the way up here, and we chuck this into a lerp. And this guy goes into the alpha, and we make sure that the B channel is set to 1, and the A channel has this guy plugged in here. See what that looks like? This. It's looking good. Cool. Now, just a couple of things to stick in here is that in the background you can still see this grid, so we're just going to get rid of that now. So if we go to the right hand side of the lerp and we right click and create a scene depth, like this guy here, and we divide this. So let's multiply this by a really big number. So what I usually do is 1024, and then I use the asterisk multiply, and I multiply it by 16, like this. So if we drag out here, and 1 minus, like this, and then we round, and then saturate, and we chuck this guy into a lerp, and the alpha here, and we make sure that this, the outline value, is in B, and A is set to 0. Apply that, and go into the scene, the background should be black. Cool. So if we go back in, we just want to add a little bit of control in between here as well. So if we create a multiply by left clicking and pressing M, and we chuck this guy into A, put this guy into B, and we right click and create a parameter, and we call this master inner outline, and set this to 1 for now. Now just before we test this in the scene, I do want to apply this to the base sort of render. So if we give ourselves a wee bit of space here, and we right click and type in scene texture, this guy here, and we set this to post process input 0, and we drag out and we mask this with a component mask, and we just make sure that it's RGB, so a vector 3, and we drag out here and lerp and make sure that it's in the A channel. Just pop this guy up a wee bit, and if we left click and press 3, we'll create a 3 vector, and if we convert this to a parameter by right clicking, and we call this outline color, and if we chuck this guy into B, and the alpha channel, if we multiply this by this guy here, chuck this guy into the alpha, and the out value we put into the emissive color, and apply. This should be applying in our scene. Cool. Now it looks like we actually have the outline, but it's just a little bit simple at the moment. So if we find our instance that we have in our post-process volume, this guy here, this guy here, like that, this up, And if we have a wee bit of a play around with this, so in our contrast settings, let's just open these guys up really quick. If we put our contrast max to something like 4, we'll start to see more detail coming in here. And our min to 0. And if we have a little go over normal sharp, and it looks like we're getting a little bit of glowing here. And I think that's because if we go back into our material here, we need to put a little saturate in between the lerp here and the master inner outline. So if we right click and create a saturate, chuck this guy in here, apply, and we go back into our scene. Yeah, that looks better. Cool. Now if we go back to our instance here, it's a little bit messy, so we need to put things into groups. So if we go back to our material, full screen this, and we go to our offset amount, and we can put the group to outline, like this. We go along here and we grab our normal intensity, the contrast normals, normal sharp, all that sort of stuff, and we pop them in a group for normal controls, like this. If we go down to our depth area, and we pop the depth intensity into depth, like this. And we can put our master controller into maybe the outline group, like this. And that should just neaten things up a little bit with this. Yeah, that looks a bit better. Cool. And the only thing I wanted to really add to this is a sort of cutout effect. Now, just to show off what I mean, if I apply my original material, so this guy here, you'll notice this green outline, and it kind of looks like it's more separate from the world. Now, to get this effect, it's pretty simple. If I just get rid of that for now, do this. If we go back into our material, give ourselves a wee bit more space here. And if we right click and type in switch, we want to create a static switch parameter. And if we name this only in custom depth, and if we duplicate this down here, and we name this switch custom depth only outline, and we chuck this guy into true, and we connect the result to false, and then the output of this to the emissive color in the node here. And with this, what we're going to do is either choose between just a full outline of the model, or if we're actually going to include the inner outline that we've been creating here. Alright, cool. So the first thing we need to do is if we drag out here and we create a lerp, and we create a 3 vector by clicking 3 and left clicking on the mouse, and we make this a parameter, and we call this outer shell color. And if we duplicate this guy down here and chuck this guy into false, and we connect the color up to the B channel here and the B channel here, this is going to be the color to the outline that's going to break up the model from the background. Okay, now we want the A channel to be the background color. So if we drag out of the mask and connect that to the A, and just double click here to make a reroute node to make it a little bit nicer. Now of the A channel here, it needs to be connected to the outline material that we've been making so far. So if we just do the same, make it a little bit nicer looking, like this. And now all we need to do is figure out how we're going to mask this. So if we give ourselves a wee bit of space here, and if we right click and create a scene texture, and in here, if we set the drop down to custom depth stencil, and if we drag out here and divide it by 255, and mask this to the red channel, and we're going to want to add this to a bit mask. So if we type in bit mask and make sure this value goes into the bit mask and not the bit. And if we chuck this guy into a lerp and make sure that's connected to the alpha. And the output of this is going to go into both of these alphas here. Cool. And one last thing is we want to make a parameter here. If we right click on the bit and promote the parameter, and if we call this outline bit value, cool. And we'll just set this to 2 for now. However, this can be whatever value you'd like, up to the value of 256. Cool. Now this will actually mask within an object, so this will be accurate to the edge of this object. However, we want to kind of like push this outwards to the overall outline that we're going to create, so that if you have a thicker outline, we can encompass that thickness a wee bit. Cool. So to be able to do that, we're going to have to do another ladder type thing, but for the custom depth stencil. Now, if you get to this point and the custom depths isn't actually working at all, what you'll have to do is go into your project settings and type in custom depth, and make sure that the custom depth stencil pass is set to enable with stencil. I think as standard it's enable or enable on demand, but make sure it's with stencil. Cool. Now if we go back into our material and go down here to give ourselves a wee bit of space, and we right click and create a scene texture, and we set this to our custom depth stencil, and we drag it here and we divide this 255, and we mask this to the red channel like that, and we chuck this into a bit mask and make sure that is in the bit mask bit there. And we take our outline bit value parameter, copy it down to here, chuck it into there for now, and we create an add just like before with the other ladders, and we drag over here and we create an add like this, and we're going to want to create these 2 vectors that we had before. So if we right click and search for sample custom, the little function that we made before, and we chuck this guy into multiply and connect that up to B, and we create a texture coordinate and mask this to the R and G and pop that into A. And out of here we're going to use a new Texel Size, so much like this guy here that we created at the start, we're going to have to create a sort of custom reroute node here. So if we go over here and we copy and paste all of this stuff up to here, give ourselves a wee bit of room, and we rename the inner outline offset to the outer shell offset, and rename Texel Size inner clamp to Texel Size outer shell clamp. Good spell. But this time, if we give ourselves a wee bit of space here and we create a multiply in between this parameter here, and we pop this into A, chuck that guy into B, and what we're going to do is create a sort of offset. So the further you get away from an object, the smaller the outline becomes. So if we right click and create a scene depth, and we divide and add a power to sharpen it up, and we multiply this to control the value, and then we saturate it for safety, and then we're going to 1 minus this. Now if you chuck this into a lerp like this and keep it in the A value, and we duplicate all of this down here, and then we chuck that into the alpha, and we pop the lerp into the B channel. Now, if you want a little bit more control here, you can create parameters out of these to play around with how far away you want it to fall off to. So what we'll do is right click, create parameter, and we'll name this depth cutoff. And we'll right click and create another parameter here. And we'll call this depth cutoff sharp. And we'll create one more here, and we'll call this depth cutoff intensity. Cool, and we'll set this to 2, we'll set this to 1, and we will set this to 1024. And these values down here, we want to set this one to our very big number from before. So if we do 1024 and times this by 16, like this, and the power we want to put to 20, and we want to leave the multiply at 1 for now. But again, you can put a custom parameter in here as well. If we apply this and save, and out of our make float 2, we want to create another reroute node. So if we type in reroute and add a named reroute declaration node and call this Texel Size outer. Cool. And again, if you're on UE4, you will have to plug this in directly to the nodes here, just whenever we mention this at all. We just call this Texel outer, something like that. Okay, cool. So if we go back to our custom depth stuff that we're doing down here, and we type in our Texel outer size, and we chuck this guy into here, into this multiply, and we just put a constant vector into here, and put it to a value of 1. We can now start to make our ladder. Cool, so first of all, if we duplicate all of this area down here a few times, just like before with our other ladders, and we start connecting up some of our data. So if we put this guy into here, duplicate this down, this guy into here, this, do this again. It's like this. Cool. And now if we add all of this together, just like before, like this, and make sure that the bit mask is actually plugged in there, like that. Cool. And the last one that we need to add is actually the 0 position. So if we duplicate one of these guys up here, create another add, like this, and the 0 position doesn't actually need any of this offset kind of stuff. So if we just directly connect this texture coordinate to there, that should be us. Cool. If we apply and save, we should be good to go. So if we drag this guy up here and connect it directly to the output for now, just to test this out, we apply and save, and we look into our scene, our material is set to the value of 2 here. So if we put this to 1 for now, and we grab our mannequin, and we go down to the detail panel and type in custom depth, and we set this to 1, we have a white mask. Sick. Now if we put this back to 3, and maybe put this to like 5. Yeah, I think this guy's 5. And we go back to our material. And just in front of this add, we put a saturate. Let's connect that guy up like this, so that it doesn't glow in the scene. And if we just bump this guy down a wee bit here, and we drag this guy up to here, to our other bit mask area, and we plug it into A, and we reconnect all of this stuff here to our final output, and we apply, and save. We go back into our scene, just with the instance here. We'll have these little tick boxes. So if we click on this guy and tick on, ooh, that's not right. If we go back into the material, oh, that'll be why. So in the material, just after the first bit mask, the lerp here, if we put this to 0, apply, save, and go back into our scene, that looks a bit better. And play around with our instance. Take everything on. Let's see what we can do here. So first of all, let's play about with the depth. So if we say maybe 1400 and we put the intensity to maybe 0.4 and the sharpness to maybe 0.5, and just so we can see things a little bit clearer, if we make this maybe a green, and if we put the bit value to say 5, we're starting to see it on the character here now, which is pretty cool. And if we put our clamp to maybe like 100 and our shell offset something a wee bit bigger, you'll start to see the effect coming into play, which is pretty cool. Sick. Now just to finish things up here, we can just have the outline by a tick box, which is pretty cool. If we go back into the material though, and add some groups to these, we can kind of just clean it up a little bit. So let's select the bit value, the color, and the outer texel parameters over here. And if we add this to outer shell maybe, something like that, apply, save. Yeah, this is a bit better now. This just cleans things up a little bit. The other thing I tend to do is put a max value on the clamps. So on the Texel Size outer shell clamp, I tend to put a maximum of 100, just so it can't be massive. And the same for the Texel Size inner clamp, which I have misspelled. So yeah, put that to 100. Like this, and apply, save. Now, something I want to mention here is that it can actually work with glass, which is kind of cool, transparent materials, and it'll take into effect all of the normal map data that you have on your models by default. However, something I just want to kind of put out there is that it might be best, depending on the style that you're going for, to simplify your normal maps. And I'll show you why. Just for example, in this guy's material, open this up here. I'll show you the normal map. The normal strength is 0.03. Now that looks okay, but if I lower it, it might look a little bit better for the style that we're going for. Now obviously in our post-process material, we can actually control how intense the normal is, so maybe that's just the best solution for your project, which is fine. However, in a case of a simplified look, it might be worth removing or simplifying your normal map a little bit, smoothing it out, just so it doesn't pick up all these crevices and bits and bobs. So yeah, that's the end of this video. I've actually been working really hard on my first game, Button Pop. If you're interested at all, or if you've got any feedback, leave a comment down below and try out the demo on Steam now. I would really appreciate it if you wishlist it on Steam, it would help me out a lot. But yeah, with that said, I'll see you guys later. Bye!